So in this video we start with coordinate geometry. We talked about what a coordinate is. A coordinate is a point on the Cartesian plane. This point will be minus 10 x first and y second, minus 10 and 6. Right? So that's what a coordinate is. So coordinate geometry deals with the geometry of coordinates. Okay, so if we're given 2 points, a point A and a point B on the Cartesian plane, we can label those points x1, y1, x2, y2. There's some things we can find out about those points. We can find the distance between those points using this formula, Pythagoras theorem. We can find the midpoint, the point at the middle of the line that these 2 points will form, or we can find the gradient. The gradient is the slope. So if we have a point A and a point B, we can find the distance between them. We can find the middle. We can call the middle M. Or we can find the slope. Oh, to what degree is this line tilted? Right? So, and the gradient is vertical rise over horizontal shift. What does that mean? The y over the x. Okay, so the formula for the distance is the root of x1 minus x2 all square plus y2 minus y1 all square, x2 minus x1. The midpoint formula is x1 plus x2 divided by 2, comma y1 plus y2 plus y2 divided by 2, and the gradient is common m and is y2 minus y1 over x2 minus x1. The change of x, the change of y divided by the change of x. If you notice, the midpoint formula is the only formula where there's an addition sign. So not to get confused, for the distance and the gradient you have to subtract the y's. Okay, so in this example, given the points P is 3 and minus 5, Q is minus 9 and 10. Determine the length of the line. Determine the length of the line PQ, or the points PQ, the distance between the points PQ. The midpoint of PQ, which is x, and the gradient of PQ, which is common m. So first let's find the distance PQ. We have the point P, 3 and minus 5, and Q, minus 9 and 10. Let's call this x1, y1. We have to label them x2, y2. If we were to find the length PQ, formula x2 minus x1 all square plus y2 minus y1 all square. X2 is 10, no, minus 9, minus x1 is 3 all square plus y2 is 10 minus 5 all square. This is minus 12 all square plus, this would be 15 all square. Come on this side. This is equal to root of 12 square minus 12 square is 144 plus minus 15 square is 225. When we add these two, we get 369, and when we square root the 369, we get 19.2 units. because the Cartesian plane deals with units. So the distance between the 2 points is 19.2 units. Let's find the midpoint. So midpoint is given as x, and that is equal to x1 plus x2 divided by 2 plus y1 plus y2 divided by 2. x1 is 3 plus x2 is minus 9 over 2. y1 is minus 5 plus y2 is 10 over 2. So 3 minus 9 will give you minus 6 over 2, and this will give you minus plus 5 over 2. This will give you minus 3, and this will give you 2.5. So we're going to put that line, those 2 points on the Cartesian plane, and we're going to check all of these calculations by observation on the Cartesian plane. And finally, the gradient m is equal to the change of y over the change of x. y2 is 10 minus y1 is minus 5 divided by x2 is minus 9 minus 3. So this gives us 15 over minus 12, which is 3 goes into both of them, 5 over minus 5 over 4, which is still 1 minus 1 and a quarter. Alright, so let's put these 2 points and see if we can observe all these things on the Cartesian plane. So the first point is P, which is 3, positive 3, that's here, and minus 5, that's here. Positive 3, minus 5. That's at the bottom there. This point is P. Alright, so, and the other point is minus 9 and 10. So minus 9 is here and 10 is here. So this is the point, and this point is Q. So let's connect these here. Good. So let's see if the midpoint, if we can measure it. Let me use the other ruler. Let's see if we can measure it to be, well, units and centimeters will be different. Okay. So we won't get the 19 point whatever. But let's see if the midpoint is at 3 and 2.5. So the distance between this line is 11.5. So you divide that by 2 and you get 5.75. That is somewhere here. As you can see, it's at 3 and 2.5. So we can see the midpoint. This is the midpoint x. Well, the gradient now, this, if we have to count in units, from 5 to 10 is 15. Remember, it's vertical rise, which is the y, over horizontal shift, which is the x. From 5 at the bottom here to up here is 15, and from this is 9 to 3, we can count to get 12. So you see 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it is 15 divided by 12, which will give you 1 and a quarter. But because it's leaning this way, it's negative. Okay. That's it for that. Next, we look at the equation of a straight line. So those 2 points, this line here can be represented in algebra as an equation and as y equal mx plus c. So you can even go back after we finish this video and try to find the equation of this line. So the general equation of the straight line is y equal mx plus c. M is the gradient of the line, coefficients of x. C is the intercept with the y-axis. Two things are needed to find the equation of the straight line always. It's pretty simple. You need two things. You need the gradient of the line and any point in the line. Any point. So in this example here, example 25 on page 327, the points A and B, A is -2 and -4, and the point B is 4 and +2. The line on a straight line, determine the equation of the straight line. We said you need two things to find the equation of the straight line, which means first of all we need to find the gradient of this line. So A, I don't want to write it back, so this is x1, y1, x2, y2. So the gradient M is equal to y2 minus y1 over x2 minus x1, which is y2 is 2, so this is 2 minus y1 is -4 over x2 is 4 minus x1 is -2. So this is 6 over 6. The gradient is equal to 1. So we can find the equation now. Using, because we said we only need two things, using m is equal to 1 and we need a point. What point? You can use A or B. Let's use B and then we're going to use A. 4 minus 2. So we need something else. Y equal mx plus c. We have the m, we need the c. We need to know where the line is going to intercept the y-axis. So we use this very same equation here, mx plus c. We know we're using y as 2, so this is 2 is equal to m is 1, we found that out, and x is 4. So from this we can find c. 1 times 4 is 4 plus c, and bring over the 4, we have 2 minus 4 is equal to c. C is equal to -2. So the equation of the line now, the equation of the line is now, we have our c and our m, so the equation line is y equal to m is 1, x plus c, c is -2, y equal mx plus c. This is the equation of the line. Of course we don't put back the 1, so this is, the equation line is y equal to x minus 2. So this is how you find the equation of the line. Two things are needed to find the equation of a straight line. The gradient, 1, any point 1. So we find the gradient, we use the equation, we need the gradient and a point. We use this equation to find c, and then we put back the gradient alone and the c with the x and the y. And that's how you find the equation of a straight line. So let's see this example here. And then we're also going to put the straight line on the Cartesian plane. And I'm going to show you something, how to determine where the line is going to cut the x-axis and the y-axis. Well, we already know that c is the intercept with the y-axis. So as long as you see c, you know, or as long as you see this number by itself, that's number c, you know where the line is going to cut the y-axis. Okay, so find the equation of a line that passes through the points P, 5 and 4, q minus 2 and 3. So solution to that, I don't want to write this back, so let me write it back. P is 4 and minus 5 and minus 4, q is 2 and 3, x1, y1, x2, y2. Two things are needed to find the equation of the straight line. The gradient 1, so we need to find the gradient m equal to y2 minus y1 divided by x2 minus x1. So y2 is 3 minus 4 divided by x2 is minus 2 divided by, minus 2 minus 5. So this is 7 over minus 7, which is equal to minus 1. So the gradient is minus 1. I must say that the gradient is not always minus 1 or positive 1 as in the other case. The gradient can be any number or a fraction as well, as you will see when we go forward. So we have the gradient. So now using the gradient, m is equal to minus 1 and any point. So you can choose P or Q. Now remember, we're supposed to choose another A. Supposed to choose A to see if we'll get the same equation. So let's try this. If we had chosen A as minus 2 and minus 4, so I need some space. I'm going to do it here. I need to find C. So y equal to mx plus c, but A is minus 2 and minus 4. So y is minus 4 equal to m is 1 and A is minus 2 plus c. So it's minus 4 equal to minus 2 plus c. Take over the minus 2. Minus 4 plus 2 equal to c. Minus 2 is equal to c. So we still get back the same c. So back to this question over here. So we have the gradient as minus 1 and we can choose any point, P or Q. Let's choose P. P is 5 and minus 4. So we need to find c. We have the m, we need to find c. So y equal mx plus c. Y is minus 4. Minus 4 is equal to m is minus 1. X is 5 plus c. So this is minus 4 is equal to minus 5 plus c. Take over that. Minus 4 plus 5 is equal to c. C is equal to 1. So the equation of the line now. Equation of the line is we put back y equal mx plus c. We put back the y. M is minus 1. We don't put a minus 1. Minus x. And c is 1. So that is our equation of the straight line. Let's draw this line. And you will see that this line cuts the y-axis at 1 and the x-axis at 1, and that is all we need. If we y is equal to minus x plus 1, if we want to draw a line on the Cartesian plane, if we find where the line intersects the x-axis and the y-axis, we can draw the line. We don't have to do the table of value as we were doing in the first video. Alright, next, parallel lines and perpendicular lines. So let me stop this video and then we'll talk about parallel lines and perpendicular lines in the next video.